Velkommen til Maskinrummet, en podcast fra Maskinmesternes Forening. Din vært er Anders Kampmann.
MSC Euribia er et af verdens største krydstogtskibe, men ikke nok med det, så er det også et af de største på verdenshavene, der er drevet af flydende naturgas. Og MSC Euribia er lige præcis også stedet, hvor vi befinder os lige nu i den her, tør jeg godt sige, lidt specielle udgave af Maskinrummet. Vi er nemlig i Holland, hvorfra MSC Euribia, som skibet altså hedder, senere i dag stævner ud mod sin, kan vi godt kalde det jomfrurejse mod København, hvor det skal navngives officielt om et par dage. Inden da, der skal vi nå at tale med nogle folk omkring, hvad det her er for et skib, og navnlig hvad det er for en motor, der befinder sig nogle dæk under os. Til det har jeg fået besøg i studiet i dag af en af de lokale folk fra Verden, som har bygget den her motor. Maikel Arts hedder han, og han er hollænder, så derfor vil jeg nu slå over i engelsk og holde resten af interviewet på den konto. So Maikel, thanks for joining us here today. You're from Wärtsilä, as I just explained to the listeners, but I think you could start out by elaborating on your role in the company, which you have been with for 16 years.
Yes, correct, Anders. It's very nice to be here with you in this podcast. I'm working for Wärtsilä. We are a Finnish technology provider with a global footprint, working, let's say, around the world. And what we do is we provide energy solutions for the marine industry, so main engines and all related systems, electric propulsion, etc. And we also supply solutions for the energy business on land. And my role as General Manager of Technical Sales is that I look after the cruise segment and basically oversee this segment. What does it need from Wärtsilä scope and solution perspective, and advising customers on, let's say, how to make their ships running as efficiently as possible, how to upgrade existing fleet, advising. A lot of my time is working on new projects. How is the next cruise ship generation going to look like? And I do this for, let's say, the cruise lines worldwide.
And you are an engineer by background, by education, so you very much have the technical insights to deal with these kind of systems.
Yeah, correct. I'm actually a mechanical engineer by training, and the rest I've learned, let's say, working in Wärtsilä for more than 16 years now. And you clearly see that the technology development has really accelerated the last 5 or 10 years, and in that flow I've, let's say, accelerated my know-how as well of new technology and technology development.
And to further set the stage as of where we are today, not only on a canal in the Netherlands, just out on the outskirts of Amsterdam, but also sitting on one of the biggest cruise ships in the world, 6,300 passengers at full capacity, 1,700 crew, so a small sailing village, really, of 8,000 people when fully occupied here. And of course, this propulsion system and the LNG engine, which is sort of the turning point for our talk here now. What can you tell us about this engine?
Yeah, you're correct in kind of depicting this vessel as a small floating village, because with crew and full passenger capacity, you're looking at in the order of 8,000-9,000 people on board. However, this is the latest edition of MSC, and sustainability is absolutely one of the cornerstones of the creation of this vessel. So from the design and building, and this is let's say, this philosophy and foundation is generating the fact that this ship is the most sustainable vessel in the fleet of MSC so far. So even though it is a big vessel, it is also having the lowest emissions per passenger, which is quite a remarkable thing. And Wärtsilä has contributed to delivering those impressive results by having the Wärtsilä dual fuel engines on board of this ship. So we have 4 engines of the Wärtsilä 46 DF type, that stands for dual fuel. That means that these engines are capable of running on 2 fuels. That means LNG and diesel as a backup fuel. LNG, that stands for liquefied natural gas. And then there is diesel as backup fuel. So in case there is no LNG available in the place where the ship would operate, then it can still continue operation on diesel. But it is running most efficiently on the LNG. We have 4 engines on board, so 2 times 12V 46DF and 2 times 16V 46DF. And these engines can be switched on and off just depending on the load that is needed by the ship. So that gives the ship about 6 sufficient operating points by switching on and off the engines. So in every operating mode, the most efficient setting is obviously chosen.
Mm. And when cruising at a normal speed is what, 12, 13 knots ish?
A little bit faster, I would say around 18 knots would be typical cruising speed. It has come down in the past, maybe some 10 years ago. It was maybe a knot or 2 quicker. But obviously reducing vessel speed is also lowering the amount of power needed to propel the ship. And that is in normal conditions sailing 18 knots, I would say 2, max 3 engines would be needed for that. So there is always, in most cases, a standby engine available. That means that they can do maintenance on one engine and still operate all the functions of the vessel safely in all weather conditions with the remaining 3 engines. That is normally how cruise vessels are designed.
And so on a daily basis, operating the engines on LNG, how does that differ from having one on diesel?
Yeah, there is quite a difference running an LNG vessel than compared to a diesel vessel. Maybe good to kind of introduce how LNG has come to the maritime industry as a fuel. LNG was already transported for decades, actually, as a fuel that was used for energy production on land. So there was already LNG carriers were already operating. There was already liquefied natural gas being transported around the world. And some 15, 20 years ago, there was a real strong focus on minimizing SOx emission, so sulfur emission. And LNG was introduced as an alternative fuel to do something about SOx emissions. And it is extremely effective at minimizing SOx because there is practically no SOx in LNG. There is no SOx actually in LNG, of no sulfur actually. And that is how LNG has been introduced. Still, when you run on LNG, you also need to bunker LNG. And this is something that has taken many years to become where it is today. It is absolutely accelerating in terms of places where you're able to bunker LNG, but it is certainly not available in every port where ships are operating. It is expanding, and it is expanding around, let's say, the main shipping hubs. But it is not available on every port. So that means that when you run a ship on LNG, especially a cruise ship on LNG, that you need to make sure that you have sufficient autonomy. So your LNG tanks need to be large enough to sustain a full round of cruising without having to bunker at too many places. So this ship is also equipped with LNG tank storage systems. It is called the LNG pack from Wärtsilä. And this is a 2 bilobe tank system. So this is that has to do with the shape of the tanks, and combined they can store 4,500 cubic meters of liquefied natural gas. And that gives this ship more than sufficient autonomy to operate for 2 weeks with all systems functioning and in all conditions. Yeah, that is sufficient to run this ship. But still, LNG is not available in every place and in every port. And to give you an example, in the Middle East, there is no LNG available, which, funny enough, Qatar is one of the natural gas hotspots in the world. But it doesn't...
kind of ironic, actually.
It is. And so that doesn't mean that even though the natural gas is available, that you can bunker it as a ship. So running on LNG really requires careful planning of the ship owner to make sure, is it available where I'm going to operate the ship?
And then there's also a slight complication in terms of bunkering and storing the LNG is a temperature of minus 160 degrees, 63 degrees Celsius. So that's kind of cold.
Yeah, LNG, so liquefied natural gas, that to make it liquid, you need to cool it down to minus 160 degrees below zero. And if you do that, then you minimize the volume of natural gas by a factor of 600. So The reason of doing that is that you then can store in a small space, relatively small space, sufficient energy. And in shipping, space is a premium, especially in cruise shipping, space is an absolute premium. So they do everything they can to minimize the space of the fuel storage solution. So liquefied natural gas is definitely running on natural gas, and liquefying it is definitely the way to go to do that. However, minus 160 degrees below zero does require special systems able to do that. So these LNG pack tanks, they are super isolated tanks to minimize the loss of cold energy. And that is basically the whole value chain of LNG. The energy losses need to be minimized by extreme isolation materials and so on. Yeah.
I know that's another feature of the ship in general to minimize the use of energy, maximize energy efficiency, and also systems to improve heat recovery from other facilities on board. So the energy needed for the cooling down the LNG is on board and obviously being produced and then used as to the best of its possibility.
Correct. It requires energy to liquefy natural gas. However, when the liquefied natural gas is on board and it is fed to the engines, it is evaporated again. So it goes into the engine as a gas. And the cold energy that is released is then reused via the HVAC system. So that is a very effective way to reuse the cold energy stored in liquefied natural gas. And that is one of the ways that this ship is able to minimize to maximize the energy efficiency by reusing that cold energy.
So looking at LNG, as you say, it's not available in any report. And the ship here, the Euribia is going to travel around the Nordic region, starting in Copenhagen, as I mentioned in the introduction, on 2 days from now. Can run for 2 weeks, as you say, on full tanks. So you have to be careful when planning. So you don't have to. You're not forced, so to speak, to run on conventional diesel or bunker oil. So it's a bit of extra planning compared to conventional sailing.
Yeah, it definitely requires additional planning from the MSC, in this case, from the ship owner to run the ship in a place where there is at least an LNG bunkering place in the itinerary that the ship is covering. And for this vessel, if I'm not mistaken, they are bunkering in Germany. So that is one of the locations that the ship in the normal Nordic route is visiting. So that would be the bunkering location for this vessel.
Husk, du kan altid finde den nyeste version af Maskinmesteren på mmf.dk under publikationer.
In general, in Wärtsilä, how do you see LNG as a propellant, if you will, for future, for other vessels looking forward, cruise industry and maybe in the shipping or container businesses as well? How do you see the potential?
Yeah, and we see that LNG is one of the future fuels that is to be used by shipping. So shipping needs to decarbonize just as well as the other industries. So we see that there are three main levers to work on as for the maritime industry. One is the minimization of energy use of the ship. That means new generation of engines with higher efficiency. That means more advanced propeller designs. That means air lubrication systems that minimizes the friction of the hull. That is one thing. The other thing is electrification. The use of shore power where that is available, or the use of battery hybrid systems that are assisting main engines to, in simultaneous operation, minimize the emissions of the whole system. And the third lever is the switch to net zero carbon fuels. And LNG is one of the first fuels that has a lower carbon footprint and which is available at scale. So these two factors make LNG a very attractive fuel option to consider, especially for the cruise industry. There are a couple of other factors which make LNG very interesting, and that is that LNG has a significant reduction in the reduction of local emissions. So if you compare to a diesel engine, then a dual fuel engine running on LNG has next to roughly 20% lower greenhouse gas emissions, also about 85% reduction in NOx emissions. It has almost practically no SOx emissions, so it almost eliminates SOx emissions, and also particulates is practically not existing. And this is one of the big benefits for example, ports and coastal communities, people living there, because these local emissions are directly impacting the clean air that they breathe in and which they would benefit from. So LNG, compared to diesel fuels, LNG is a step in the good direction from greenhouse gas perspective, and it is a massive step in the good direction from local emissions perspective. And then to add to that, if a ship is running on LNG with Wärtsilä systems, it can also run on bio-LNG. So that means LNG, but then produced from bio-waste. That can be household waste, that can be municipal waste, like sewage sludge, that can be agricultural waste. Manure is a very effective feedstock to produce bio-LNG with. So bio-LNG, by definition, is a carbon-neutral fuel. And this can be blended with fossil LNG at any given ratio at any given stage, and it does not require any modifications to the engines or the LNG infrastructure. And that is a very attractive transition potential, because with the same systems on board of the ship, it can run on fossil LNG and it can run on bio-LNG when that becomes more and more available.
Mm. And availability at scale is really a key word here with LNG. I can sort of gather that's really a jumping point in terms of widespread usage. It is actually on market and there to fill the tanks.
Yeah, correct. We have seen, of course, the last few years since the war in the Ukraine started, a big swing in the energy prices, including in the prices of LNG, and that had all to do with the fact that Europe and the rest of the world didn't want to rely on Russian gas anymore, and that has led to an enormous upswing in prices. But that was not due to the fact that LNG wasn't available or natural gas wasn't available, because there is so much natural gas. We have basically just scratched the surface in terms of how much natural gas there is in let's say, the natural resources. That makes LNG an attractive fuel because the feedstock itself is available. If you look at the other alternative fuels like methanol, ammonia, or hydrogen, they don't exist as such. They are all need to be produced, and the infrastructure to produce those fuels that is not existing. That still has to be done, and that makes for LNG, you can say it is at least available today. It is a step in a good direction from all perspectives, greenhouse gas emissions, and especially on local emissions, and it has this transition potential. So it is definitely one of the fuels that ship owners should need to consider very much.
Mm. We know that Maersk is looking into, or not looking into, that's an understatement. They have ordered, I think it's 8 methanol vessels, 8 or 10 vessels from that are being built in I think South Korea as we speak, pretty much coming into service in a couple of years. So there's gonna be a whole infrastructure build up coming up, and I guess also a question of the whole power to X sector being ramped up. So how do you see a fuel like methanol or ammonia, for that matter?
I think that methanol is also a very attractive fuel to consider for ship owners. The attractive point for methanol is that it doesn't require cryogenic storage, so methanol can be stored at room temperature. It does require a special treatment in terms of other systems. For example, you need an inert gas blanketing system because the methanol vapors are have a low flash point, and so for that perspective, it has certain safety issues, but with the technology, they can be dealt with. And we also see that the cruise industry is carefully looking at methanol as a fuel. In fact, we also have a signed contract with the ship owner that is building a methanol-powered cruise ship. That is Celebrity Edge number 5, which is built at Chantier de Atlantique, and that has also Wärtsilä-capable methanol engines on board. So both LNG and methanol are considered very attractive options from a decarbonization perspective. Still, point I made earlier, LNG is available today. Methanol still requires an infrastructure that needs to be built up in terms of production and bunkering infrastructure. And we have seen with LNG that infrastructure is not easy to build up. And we also see that decarbonization is accelerating fast. So there will also be lots of users for the green fuels, and availability is going to be a key issue for this industry to succeed. So you can't ignore LNG, but definitely methanol is also an attractive option, and it certainly has some very strong points. When it comes to ammonia, we are also developing engines that are capable of running on ammonia. However, from the passenger segment, this is perhaps not the most logic option. With ammonia, even the smallest traces, the human nose is extremely sensitive for that. And the way it is looking now, we see that the safety regulations on ammonia and the type of systems needed to comply with that will be more invasive from, let's say, a shipbuilding point of view. And then if you look at passenger vessels, cruise vessels with thousands of passengers on board, it is maybe not the most obvious fuel. However, in this day and age, you can't rule out anything, because technology development can really go quickly, and things that are maybe hardly imaginable today can be very different a year or 2 years from now. Yeah.
So all in all, the cruise industry, which is, let's be honest, really energy intensive in many ways, is looking into, at least when it comes to propulsion, a more sustainable future.
Absolutely. I think that cruising, if you look at the cruise industry, they have really embraced this net zero cruising in 2050. Cruising companies like MSC are investing heavily in cleaner vessels, in ships that minimize the energy reduction, and every new ship generation is really making quantum leaps ahead in terms of the minimization of energy consumption, in introducing new fuels. More than 50% of the all the cruise vessel new buildings in terms of capacity are powered with LNG, and that gives you an order of magnitude how quickly this industry is accelerating the decarbonization. And from that perspective, it is literally leading the decarbonization in the maritime industry. At the same time, there are lots of existing vessels out there working, and a cruise ship easily has a lifetime of 35, sometimes even 40 years. And that makes that cruise lines are also very much investing in upgrading existing vessels. And maybe from an upgrading perspective, so if you would like to convert a ship from, let's say, heavy fuel to an alternative fuel, in that case, then methanol would be an attractive fuel, because the impact it has on the vessel is still not insignificant, but it is doable, and the technology exists to do that. In fact, Wärtsilä has converted, together with Stena, an existing ferry operating in the Baltic, that is the Stena Germanica. This ship is converted to run from heavy fuel oil to run on methanol. So we have modified the engines, and Stena with the shipyard have modified the fuel tanks to be able to bunker and store the methanol on board. This project was started in 2015, so we're 8 years further, and that ship is running very successfully, off and on methanol. Depends on the availability, if that was available, yes or no. But from a technology perspective, a lot of the solutions that we need are actually already available today.
Husk, du kan altid finde den nyeste version af Maskinmesteren på mmf.dk under publikationer.
So very interesting perspectives and for the industry at large, and container shipping industry as well. I can see a greener future, as we said.
Yeah, absolutely. Yeah, clearly the container lines are, let's say, the workhorses of the maritime industry, and they are also very much in the forefront when it comes to maritime decarbonization. And companies like MSC, like Maersk, like CMA CGM are absolutely also leading the way. And in those companies, you also see LNG. You see that methanol is being introduced, so ships capable of running on those fuels today. I think that I know that they are also carefully looking at ammonia and hydrogen, maybe a few steps further away. But as I mentioned a moment ago, things that seem very difficult or almost unimaginable today could look differently a couple of years from now. So
really exciting then to follow the development in the sector, all in all.
Yeah. That's maybe an understatement even, Anders. I think that from the maritime industry, we live in the most interesting decade since as long as I can remember. And I've also spoken to many people who have worked in this industry for close to 40 years. And
maybe since developing the coal engine.
Yeah,
almost.
Well, that could be because the development in emission regulation, the development in technology to meet or beat, let's say exceed even that regulation, is going so rapidly now that as I mentioned a couple of times ago, things that seemed almost impossible suddenly look very differently because the technology progress is going so fast. I think one of the key drivers in this is that the IMO, the EU are working hard to implement new emission regulation. What we as an industry could use more is more harmonization between the regulation and actually more decisions, so that companies know where they stand and that they can then plan their their technology investments related to that. But the EU is going to or has implemented the EU ETS, so that shipping needs to pay for its carbon emissions. That is, of course, a big driver in the uptake of new technology. The IMO has introduced the carbon intensity indicator, which is also a mechanism that really enforces ship owners to minimize the emissions. And since this is a downward trending emission compliance scheme, ship owners need to year over year improve the emission profile of the vessel. And by these regulations, you clearly see that the technology providers, the classification societies, shipyards and ship owners are more and more working in the same direction to minimize emissions, introduce new fuels, and this is only accelerated in the last couple of years.
Super exciting perspectives. Glad to follow the development from here on. Maikel Arts, thank you so much for joining us. Og til jer derude, det var Maskinrummet for denne gang. Vi lyttede ved.
Du har lyttet til Maskinrummet, en podcast fra Maskinmesternes Forening. Find flere podcasts på mmf.dk.